let's see what we have in the Weka. Okay, you can open the data set. I assume everybody have already done this, ya. Maksudnya you have prepared the data. Huh? Betul tak? Everybody have done this part, right? So you have the CSV file. Okay. Now you open it. If you look at your data set, okay, let us make comparison to the data set. Yeah. Okay. Okay, as you've seen here, we have MPG continuous, and then we have cylinders. It's a multi-value discrete. Yeah, originally the data is a multi-value discrete, and then we have displacement. Okay, you can scroll down to see the minimum and maximum value of each variable. Okay, right. And then you can see horsepower, and then you can say weight is continuous, acceleration is continuous. Model here is actually multi-value discrete. Okay, origin also multi-value discrete. Okay, from this data set, okay, and if you refer to this description, do you think which of the variable, yeah, which one of these variables are actually the outcome or the target?
Miles per gallon.
Okay, how do you get that?
Oh, for the original data set, are we talking about the original data set?
Yes,
or
yes,
the
yes.
or
This
the original?
How do you get it?
Intuition.
Okay, that's good. Actually, if you look at the description, it's already put here. Yeah, the line that used by the Ross Quinlan is predicting the attribute MPG, means that the miles per gallon is being used for the target. Yeah, so it's actually a dependence variables, and the rest are independence variable, or we can call it that the MPG is the output or the target, and then the rest will be the input value or the variables. Yeah. Okay, now if you look back to this, yeah, if you can recall, yeah, your ARF viewer. Okay, so we can access ARF viewer from this menu. Go to the tools, ARF viewer, or we can go here. Yeah, in this pre-process tab, you can click to the edit. Right? Can you see it? Right. So now if you look at your data, it has 3,000 something, and then these are all the attributes. Okay. So what we are going to do today will be based on this data. Okay. If I may recall to you, yeah, in the future there is a description about regression. Where is it? Di mana? Can you recall? Where is it? The regression part. It should be here. Okay. In the task. Yes, in the task and techniques. Okay. And if you look at the slide, yeah. Here. Okay, this is classification, this is clustering. Okay. And then we have associations. Okay. And next will be the regression. Okay, so regression is one of the tasks or the task that we refer to the prediction of the continuous value on the target. Yeah, for the target. Yeah. So one of the regression techniques. Yeah, so we are going to try one of the regression techniques available in the Weka. Okay, do you have any idea? How going to what is regression? Can you relate with any your existing knowledge atau prior knowledge? Regression, if you look at this chart, okay, can you see this chart? Okay, and then in this chart it has what? It has apa dia? It has numbers here, 0, 50, 100 and so forth, and this is axis X, betul tak? Okay, and then this is this y. Okay, if you can read it into the trend line, yeah, is referred to, for example, in this case, is actually predicting sales amounts for a number of product based on the advertisement expenditure. So we are assuming, yeah, the x is the expenditure, yeah, expenditure, and then what will be the sales based on the how you expand the advertisement. Say like if you look at this graph, you can see a formula. What is the formula?
The straight line formula?
The straight line formula. Okay, can you see any exact formula?
Y equal to mx.
Yes, y equal to 0.47x plus the. So y equal mx plus c, and y is the outcome, the target. Okay, 0.447 ni reflects to what?
Gradient.
Is reflect to gradient ataupun m lah, coefficient lah, mx, kan? And then plus 1962.23. What is this?
Intersection.
Yes, good, very good. So you should see the intersection of the line. Okay, actually there is a line here. Okay, it's quite tiny. Yeah, I should use another color. So this is dots. Yeah, these are all dots of the data. Means that based on the actual data, means how much they spend, and this will be the sales. Okay, how much they spend, and this is a sale. So trend lines is actually finding the best fitted line. Okay, so the tiny lines is actually the best fitted line. Okay, so this is what we call as the trend line. So we are going to have this one. Okay, and then using linear regression also, we can have the formula. Okay, so this formula is representing the best fitted line. Okay, and later on, you can use this formula for what? Why we want to get this formula?
To make predictions.
Yes, for make prediction on the outcome based on the the new data set, isn't it?
Betul.
Okay, so this is what we are going to do today, right? So go back to your data now. Okay, so these are the data set. Okay, so we focus on the continuous. Remember just now I show you this is a continuous, yeah? So it's using variables that are continuous. So how are we going to deal with this data? It has continuous, multivariate, discrete is actually nominal. Okay, so how you going to deal with this data in Weka? Any idea?
You need to set the miles per gallon as the class. I have to repeat first.
Again, amboi kamarul, panjangnya jawapan awak.
Oh, sorry.
Okay, it's okay. It's actually we want to do is that we just want to use the continuous. Okay, so what are the continuous variables? It should be MPG, and then
displacement.
Yes, displacement.
Power.
Horsepower. Okay.
Weight, acceleration.
Acceleration. Okay, the rest, what you need to do with the rest? So you see the button here? Button in. Yeah, this is to remove lah. So we want to remove the other, so we on the invert. Okay. Click invert, and then you can see that cylinders is been take. The year is take, origin also take. Why? If you want to look at this data, cylinder, okay, how you see ataupun how could you relate into the discrete value, because it has three clearly discrete value. Three, bars, bars here. And then if you look at model year also, model year will be started in developed in 70, right? And then up to 82, yeah. And origin is actually here. If it's already been pre-processed, it's been presented 1, 2, 3. It's actually, if I can recall to the original data, it's presenting whether it's been built in Europe, yeah, in US and another place, I'm not sure. So this would be the origin lah. So there is a discrete value. It's rather than, however, when we have we do I mean, when we put it into the CSV, Weka will detect it as numeric, but the real life is that it should be discrete lah. Yeah. So we want to remove this data. Okay. I mean these columns, right? So you can click remove. Okay. So now this will be the data set. Yeah. In your data set, we'll have only 5 attributes. Okay. Let's have a look at your data again here. Right. Okay. If you look at data here, okay, what does it mean by bold here? Any idea?
It is the dependent variable.
Okay, it is an independent variables, or this is the target. Okay, we are talking about, we want to predict the MPG, yeah, the miles per gallon. Means that we want to look at displacement. We want to look at the horsepower, and we want to look at the weight, and also we want to look at the acceleration of the car, and how this variable determine the miles per gallon, how it consume the fuel, yeah, ataupun petrol. Okay, so we want to set the MPG as the target. So what do you think? Do you think it can be done here?
Yes.
How?
Right click.
Okay, good. Right, so you can go to the MPG and then you right click, and then you can see which one you should choose.
Attribute as class.
Yes, attribute as class. Okay. So when you click to write attribute to the class, so it will change into the rightmost. So the rightmost attribute means that is a target. Okay. Right. Saya tak set. Okay, dah ada yang ni record. Okay, thank you. Alright, boleh ya? So now if you look at your data set, you click OK. Remember to click OK. So now MPG already been assigned as the target, yeah, or it has been the rightmost variable. Okay. Alright. Okay, have you done this? Okay, if you look at, you can, okay. Now this is part of the pre-process lah. Means that if you look at the data and then you already know which attribute should be the input, which attribute is the output, they should be done in the pre-process. Okay, and then which attribute will be relevant to the modeling, which attribute need to be removed, this also can be done in the pre-process. It's part of the pre-process mode. Okay, now if you look at the menu in the Weka Explorer, classify is been able, cluster is been able, associate will be able, and select attributes and also visualize. Okay, so these are the, these are among tasks that we are going to explore for data mining class. Okay, so today we are going to use a classify menu, yeah, and to do what? To make prediction on the continuous data, right? Okay, have a look at here. You can see there are buttons here, choose, okay, and other below of it is the test mode. Okay, I'm not going to explain detail on the test mode. We are going to discuss this later on in the classification and also in evaluation. But have you seen here, there is a button here that you can click, and you can actually, yeah, you can actually, if previously you see that the arrangement of the attribute is not, the target is not been in, is not be assigned as a class, or is not being as a rightmost column, you still can change, yeah, you still can change by manipulating this button. Means that you can change the variables, you can change to displacement, you can change it to horsepower, or you can change it to the MPG lah. Okay, so currently we have already assigned MPG as the class level. Automatically it will put the auto MPG as the target or the class. Okay, right, so have a look at the classifier. Okay, so this under classifier, when you click choose, Okay, and then you can have a package Weka here, library of Weka. Under library of Weka, you could see classifier. So there are so many classifiers algorithm. You can click to bias, you can click to the functions, okay, and then you can click to the lazy, right? You can click to the meta and so forth. Okay, whichever algorithms that is active, yeah, maksudnya is not in gray, so means that you can use this algorithm. Okay, so lazy, if you look at under lazy, there is IBK. IBK is actually presenting the nearest neighbor, yeah, nearest neighbor algorithm. When you bring your cursor to the IBK, you can see the description of K nearest neighbor classifiers. Yeah, and you can also bring to other algorithms too. Okay, now we want to do linear regression, right? So go to the functions. Okay, now we have seen here under functions there are two linear regression. Okay, we start with the simple one first. Yeah, so click to simple linear regression. Right? Okay. So means that here we have chosen this the algorithm. Okay, make sure this one is already assigned as MPG, and then you can click start. Okay, everybody should get this output. Okay, what does it show? Okay, it shows here. You have used the classifier for 398 instances with 5 attributes, yeah, and it's applied 10-fold cross validation, and for this data set, the Weka already identify the linear regression, or the formula for the linear regression is on width, yeah. Okay, so anybody can describe this formula? Anybody can describe for this formula?
MX plus C.
MX plus C. MX, what is the X value? X variable?
Wait.
Wait, very good. All right, so wait, let me here. I don't see your face. Okay, so let me put it here. Okay. Right, so the mx plus c, so why mx plus c? So m is the slope, yeah, or the coefficients, yeah, times width. Width is the variable, the x-axis, yeah, and plus 46.36 is the intercept. Okay, and what is the y? What is the y?
MPG?
Yeah, good. So we are using this formula to get the MPG. Okay, right. So now we have the formula. Okay, and then you want to see what is the measures for this formula. So it's shown here. Yeah, correlation coefficient is 0.829. Yeah. So it shows the correlation. The best correlation should be 1 lah, yeah. But this one it shows 0.829. Okay, and then the other things that would be important would be the root mean squared error. It should be nearing zero lah. Means zero is when the ideal case. There is no difference between the actual versus the predicted. Okay, right. So everybody understand this one? Okay, and then the next question would be, okay, so how we are going to use this formula to forecast something related to the MPG? Any idea?
We save the model.
Make it simple apa dah? Simple description, Kamaru.
Use this model to predict unclassified data.
How are you going to use this model?
we save it first?
Okay, that is the technical part. But if I'm asking you, okay, now we have the formula, okay, and then I want to know the MPG. Okay, so it's very direct actually. Yeah. Weight, good. Yes. Okay, so we use the weight value, right? So for example, I'm having a new proton car now. Okay, and then I want to know what is the consumptions of the fuel, yeah, for my proton. So let me check my weights of the car. So when you buy a new car, normally you will have the specification of the car, isn't it? Betul tak?
Yes.
Yes. Okay, so you can you can replace the value of weight of my new car with in the formula, and then you will gain a predicted value for the consumptions. Yes, the MPG. Clear? Right. So you can try this formula in any type of vehicle, for example, yeah. But this any vehicle tak boleh jugalah, because this data is being trained for car, kan? For car. Katakan you have a truck, you have another, for example, like motorcycle and so forth. The way you train should be very specific on samples that belongs to can be classified as motorcycles only. If not, your model, your model should not be generalizing different type of vehicle, so it should be focused on certain type of vehicle, so it will be giving you more accurate result lah. Okay, so that will be in the context of having the data set, significant and relevancy of the model. Okay, right. Okay, the next thing that I want to show, okay, this part is clear, right? Okay. Means that we can have the formula, we can extract a formula from a training set, okay, and then we can use later on this formula to predict something new, something new on, if you have a new car and so forth, right? Okay, let us look at how we are going to view the model. Okay, so at the result list, okay, you can right click at the result list, okay, and then click to the visualize classify errors. Okay, can you see something like this?
Yes.
Yes. So this is the MPG.
Yes.
The MPG. What is MPG? MPG is the actual result. Means not the actual result. The actual data lah. This is the actual data. Okay, let me put it here back. Yeah. Saya keluarkan data yang kita dah proses tadi. Okay. Okay. So this will be the data that we have put into the linear regression just now. Okay. Apa saya nak cerita tadi? Oh, okay. So this is the MPG, So this is the actual consumptions, the fuel consumptions of each car, and then when we come up with the we apply in the linear regression, it produce some kind of trend line that can be used to predict how the consumption is how consumption of each the vehicle or the car. Okay, now this is the MPG actual X. X is referring to the actual of MPG, and Y is actually referring to the predicted MPG. Okay, so that you actually can go to here. For example, this is a big X here. Okay, you can get the information of the point here. It's actually referring to the instances 3, 4, 6. And these are the value of the displacement, horsepower, weight, acceleration. Okay, and then the actual MPG is 11. It's consumed 11. It's consumed. It goes to the 11. When it goes to 11 kilometers, that will be for one gallon. Okay, and then for the predicted MPG, yeah, actually the formula predict the vehicle can go for the 18, yeah, 18 miles per gallon. Okay, so you can have a look at another point like this. Okay, and also okay, and this one. Okay, so this will be how you visualize. Okay, now let's have a look at, okay, we want to use, for example, weight, right? Okay, so when we run it in the linear regression here, yeah, it use ataupun it identify weights, yeah, it's identify weights, and this will be the the weight will be at the X, yeah, the weights of the vehicle, and this will be the predicted of the MPG. Okay, if you see that, this will be the best fitted line. Okay, but if you look at the original data, it will look like this. Okay, so imagine that, you have to imagine that this will be the straight line being produced from the original data set like this. Okay, all right. So this part, this part also, if you see that, kenapa dia pilih weights, ya? Probably you want to questions, your data. Okay, then you can try to look at, the patterns of other variables towards the target, Like, for example, you go to the displacement. Okay, and then it goes to the horsepower. Okay, if you look at this data, actually each of the variables, except acceleration, all the variable actually negatively correlated, acceleration, it give like actually some things towards, increasing, means that when the number of the value of acceleration is increased, the mass per gallon also could be increasing. So this is what we call as the positive correlation. Meanwhile, when it behave like this, means that when the number of the value of the what we call X value is increasing, but the mass per gallon is decreasing. So this is how we see a negative correlation. Okay, so this will be look like this. But okay, right. So this this is how we want to view. Okay, another thing is that what you would like to see would be okay, this one. Okay, so as I said to you, this one correlation efficient, shows the positive and negative, means that the value of correlation itself, it should be increasing to, the maximum should be 1, the best correlation shown, and the root mean squared. Okay, if you want to relate to this output, to the concept of linear regression, you probably want to look back what is the simple linear regression. So you can click here, okay, and then go to more, okay, and you can see here. Okay, what the model, what is the algorithm did was, it's trying to pick up the best attributes, with lowest squared error. So this is how you get from the Weka, it pick up only 1. Okay, and for linear regression in Weka, it should be in numeric. Okay, all right. Okay, this part okay, everybody?
Okay.
Right?
Faham.
Okay, faham Okay, now is that all that Weka can do? If we learn about machine learning, Actually, we compare to the conventional methods. Machine learning should know, should be able to combine or to make a relationship between multiple variables. Okay, this one is quite considered like conventional methods. Like you have learned it during your maths, you have learned it during mathematics, SPM last time, right? So we want to look at other methods, machine learning concept that can correlate all these variable, yeah, of three variables in the data set. Okay, let's have a look. Another option here. Okay, and then you go to the go to the choose. Okay, and then go to the linear regression. Right. Okay. Okay, let's have a look how different the outcome of linear regression compared to simple linear regression. Okay. Everything will be by the following what default value given in Weka. Okay, make sure it's also auto predicting MPG. Okay, and then you can click start. Okay, what do you get? Apa yang dapat?
A new model.
What the new model? What is the new model shows here?
This time we use 2 variables instead of 1.
Yes. Okay. If you see here, you can have MPG equal to coefficients of horsepower and also coefficients of weight plus the intercept, a new intercept value, isn't it? Okay, and as we see just now in the visualize, both horsepower and also weights have a negative correlation. So that's why we see here it still have the the coefficients is in the negative value, isn't it? Right. So this is a new model. Okay. If you compare the simple linear regression, it could be much more better, a little bit. If you see previous one, the correlation is 0.829, very small difference. Now you should get 0.833, yeah. And if you look at the roots mean squared error, previously is 4.366, yeah. Meanwhile, this one is 4.3197. It's increasing lah. It's smaller. Yeah? The number of mean squared error is decreasing. So we could say that this will be much more better models compared to the previous one. Yeah. So horsepower and weight actually combinations of attributes that could be used and more significant in predicting the mass per gallon for different car. Okay. Okay. So this is the suggestion by the linear regression model. Okay. Still, you can also have a look at the trend line. How does it show here in the trend line? Okay. So this will be the data auto MPG. Let's have a look at the weights. Okay. A new trend line lah. Okay. And then it's also using just now what we call as horsepower, isn't it? Yeah. Okay, a little bit different compared the previous one. Okay, so yes, so this is how we get it, yeah, from the linear regression. Okay, actually, we might want to see the implication of using linear regression, but can we, for example, want to integrate or we want to use all variables? Okay, so let's have a look at here. There is an option here where just now is actually we are applying the M5 methods and also M5 methods, right? Okay, now we want to ask Weka to use all variables. Okay, so for that case, you have to choose no attribute selection. Yeah, let the rest as what you see in the default. Yeah. Okay, and then you click start. Okay, so now can you see the difference? Yeah. Right, so now you should able to see apa dia.
Using all of the variables?
Yes, okay, it will use different variable, different set variable, and then you can have a look at here. How about the coefficients? Okay, how about the coefficients? Do you think that the coefficient is much more better or this is decreasing?
The difference isn't that big, actually.
Yeah, okay, it could be quite small, slightly difference, yeah, but not much. Okay, when when we want to have a model, yeah, one of the best practice is that, yeah, we probably not to need not we don't have to use all the variables. Okay, somehow we can use a very certain, yeah, we can identify certain variables, and it could be 50% from the variables, and it can give or yields the best or a good result, yeah, comparable results using all data set or all attributes, yeah, and technically it will relate to the context of processing, yeah, processing the models. If we are using smaller number of attributes, yeah, the processing will be much more faster compared you use all the attributes, yeah. So that will be related to the select attributes, yeah. Later on we are going to touch on the select attributes under the data preprocessing. So select attribute could be one of very consider important task under data mining, yeah, because if you are having a big data set, yeah, you have too many columns. Okay, are you going to use all columns? Sometimes it is not necessary to do that, yeah. So you need to look back to the processing power. You need to look at the efficiency power, efficiency criteria or factors. So you need to look at the attributes relevance, yeah. So that's why here somehow if you look at if you want to compare between the model using smaller size of data, could be performing at par or much more better compare using all attributes. Okay, right. So actually, this is what we are going to have today. Yeah. Right. Yeah, actually, I have provided you the form, yeah, but I'm using the existing data set that you have done. Okay, probably later on, if you want to try this set of data also can be done. This will be a new data which will be very small data, just for exercise to look at the what is the implication of size, house size, lot size, or number of bedrooms, whether the house has granite or not, number of bathroom, does it affect to the selling price. Okay, and then you can look at the regression model affect to the predicting, yeah, the sales or the what we call selling price. Okay, and then you could see the difference between when you apply 2 attributes, when you apply 3 attributes, or whether you want to apply all attributes, does it affect to them. One is the coefficients, correlation coefficients, and another one will be the root mean squared error. Okay, and later on you should able to understand, yeah, when we have given you a new data, how you're going to use to predict this new selling price for the new data set. Okay, right. So any questions so far?
Doctor,
Yeah.
since we are trying to predict a continuous value,
Mm-hmm.
is that why we delete all of the non-continuous variables?
Yes, that is the purpose, because the linear regression only consider the numeric or the continuous attributes. Yeah.
All right.
Okay.
Got it.
Right. Next one, probably you can try another task. For example, you have a look at this under functions. Anything that you are familiar with?
Multi-layer perceptron.
Yes. Okay. Can you try for multi-layer perceptron? I give you 2 seconds to look at 2 seconds, 2 minutes to have a look at the model and describe your finding.
I think the accuracy is 83%.
80%, yeah. So how about the rest?
Doctor, is it normal for us not to have the same value as yours? Your maybe my data is missing or something.
Yeah, probably. Yes, probably.
Yours 50 and mine would be 48.0959.
Okay, probably because of here in cross validation, because it will the way that Weka will do something on the random sampling, so it might affect to your result as well. Yeah?
Oh, okay, understood. Okay, thank you, Doctor.
Anything else? Okay. Okay, have you tried?
Yes.
Dah cuba. Okay, anything different?
The model is different. The formula is different for multi-layer perceptron.
Okay, multi-value perceptron. Okay. For now, what do you understand about multi-layer perceptron? Do you have get any exposure on the MLP?
NLP?
No.
Belum lagi, ya. But you are currently taking this subject together with data mining. You are soon going to understand about the MLP lah. Okay, so MLP is one of the neural network, right? Okay, it's a neural network algorithms. Okay, if you look at MLP, when we click to the NLP, okay, you can click start, and this will be the outcome of the model. Okay, do you have any idea of what is this? What is this? Huh?
Those are the neurons, the input layer, hidden and output.
Alright, good. So you know that this is actually presenting the architecture of the neural network. Okay, actually it's showing the weights of each nodes, right? So you have the input nodes, and also you have the this is 2 sigmoid node 1, sigmoid node 2. This is a 2 nodes in the hidden layer, and this is the output layer. Okay, you probably cannot see much here. Yeah, and then here correlation coefficients, it shows 0.166. So comparatively to the one that we have just now, correlation will be slightly decreased. And how about the root mean squared error? Root mean square error also larger from the previous one, so it could be yeah, a little bit difference, yeah. But okay, what I'm trying to show also here, yeah, you can click to the text board, look at the generic object editor. Okay, click GUI to true, and then click OK. The rest should be the rest should be all the parameters involved in the ANN lah. Hidden layers, number of hidden layers, learning rates, and so forth lah. So I let it like default value. Okay. When you click start, so this is what you can see. Okay, so this is the input layer. In the green color, these are the input or the variables, set of variables, and then it's linked, is connected to what we call as the hidden layer. This is the sigmoid. If you look at this sigmoid, dia tak keluar lagi. Okay, you have to accept it first. Start. Okay, accept. Okay, once you accept, you can see what is the sigmoid void. I mean, the weights value of each neuron here. Okay, right, and then this will be, this is the model. So this is the model. So neural network definitely show your model in the neurons and also architecture. Just now, what you see in multi-layer, in linear regression will be the trend lines in what we call y equal mx plus c. So these are the two different models that you have developed using regression, and regression from one is from the not regression. These are the two models that you develop for predicting continuous value using regression, and another one is using multi-layer perceptrons. Okay. Okay. So once you, in the context of ANN, you should, after you have seen several iteration, and then you see that this is will be the best finding for your ANN, and you agreed to accept or to accept this ANN with certain formulation of the weights. So this will be used for the prediction of the new data. Okay. Okay, and I think that will be the important parts of having the model, simple model. It's a very simple, this is a very simple exercise, but my point is that you are using Weka to look at how you develop several type of model, and we start with a very basic model, which is simple integration, and simple integration using only one attributes, and then we expand it to another model that able to look at the best combination of attributes. And if you want to test another experiment, we want to do another experiment using all attributes also can be done, and later on we compare with another algorithm with each ANN. Okay, any questions?
What's your favorite algorithm, Doctor?
Don't ask me about that, because we actually, if I look at the algorithm, so each of the algorithm has their own capability and also own, benefits. It's always, when we have data, we really need to look at the data itself, with the data pattern, the data, and then we would need to try many variables, combination of variables, and also try to look at different algorithms. Okay, if you look into the literature currently, they are not using only a single variables. No more. It's no more like that. So there are another way of handling data by using multiple combinations of algorithms. So this is what we call as the assemble methods. Assemble methods means that it gain decision through collective or mutual consensus between different sets of models. Okay, it was like you are currently having a policy, you are a policy maker, you want to make up a policy, definitely a single decision or one decision maker should not able to give a good outcome, yeah, because different people see in different contexts. So same goes to the model itself, yeah. So there are certain models very good in numbers. I mean, if you are dealing with numbers like this, yeah, you might use ANN, you might use, for example, random forest, okay. But when you deal with nominal, is it neural network the best algorithms? There will be another type of algorithm can be applied, yeah. So that will be I mean, yeah, you have tried lots lah, yeah. All right, you have a stop here. Okay. Right, so if you look at this ANN, it need to start and set, because I have set here is tenfold, so I have to finish until tenfold, so, yeah. Okay. Okay, and then I can see the result after I finish the tenfolds. Okay. Right. Kenapa saya tak boleh bawa ni? Let me bring my my cursor, my Windows. Okay, bring my Windows. Okay, so any questions anymore? Anything else?
Yeah.
Okay, everything okay?
Yeah.
Right, so I think that's the main agenda that I want to have for today. If you want to explore, you can try to explore other data set. For example, if you want, if you look at the Weka itself, yeah. If you look at the Weka itself, you can go to your PC and then you can go to the here, okay, and then you can go to the program files, and then you can go to the where is it? It's the kenapa tak ada di sini? Okay, program files, other program files, okay. Okay, and then have a look at data, ARMF. Okay. So you can look at CPU. CPU is another data set that can be used, or it is a numeric. Yeah, all attributes are in numeric. So this data set also, it can be tested using simple linear regression and also linear regression and multi-layer just now. Yeah. Okay, so I guess that's all for today. Yeah. The other thing that I will explain in tomorrow, for tomorrow, I'm going to explain a little bit on the data type here. Okay. As you see here, there are data type, two data type here being accepted by Weka, which is numeric here. Yeah, and when we have a numeric data, what will be the measures shown by Weka? There are here minimum, maximum, mean, and also standard deviation. Okay, Probably later on we will see if for nominal, data nominal, if we already discussed last week, yeah. Another data set could be string, yeah. You can have a look at under routers, yeah. So router string. Okay, open. Okay, so this will be another view of data in the format of string. Okay, if you want to see the data, it will be like this. Okay, so this will be the string. Okay, and it has a review. It's a comment of each of the records. Okay, so meaning that if you are dealing with text later on, you want to do some kind of text processing, also can be done in Weka. Okay, right. Okay, maybe you want to explore in this. Okay, yang ini tadi saya nak explain. Okay. So this is also this is actually known as scattered plot. Saya lupa nak introduce tadi. Ini kita panggil apa? Scattered plot. So this is scattered plot. So this will be way that we can explore. Use the plotting to look at the pattern, look at the behavior of the data, and then probably you want to not necessarily if you learn data exploratory, we want to look at the dependence of each. For example, my seed and another variable, my mean. So is there any correlation between these two attributes? This one also will be discussed under topic 3, data preprocessing, to look at the correlation of each attributes, and if it has a specific correlation, what you are going to do on the attributes ataupun the variables. Okay. Right. Okay. Anything else? Hope that you can record your attendance as well. Okay. I think I will remain through online ataupun ni. Okay. If you have any question, you can still give ataupun ask me through the chat lah. Okay. So if there is no question ataupun kalau tak perlu apa-apa lagi, you may leave and continue to explore this part. Without the without online engagement. Okay, so you may leave. Saya still ada dalam ni dan saya still dalam chat. Kalau ada apa-apa perlukan, you can always call me. Sekejap, tak perasan. If you want to solve a classification problem, do we have to delete the continuous attributes? Okay, actually, we are dealing classification. Okay, now let's have a look. Can you, because Kamal is asking, okay, saya kena keluar dulu daripada ni. Actually, okay, let us try. Okay. There is classification, and then I want to do other tasks. Oops. Okay. Remember that we have done in the lecture session last time. Okay, there are certain limitation. Yeah, actually algorithms have certain limitation. Okay, let's have a look at this. Okay, now if you have this data, okay, you can see that linear regression is able, multi-layer perceptron is able. Okay, let us check under trees. Okay, so if you look at tree here, okay, random tree is able, and look at J48. J48 is disabled. Okay, now I change my data into another set. Okay, let me change data into another set. This will be using the one that has nominal. Okay, kita tengok weather. Okay, baik, mana data weather saya tak keluar pula. Weather. Right. So when we have a nominal data set, okay, and then you go to here, you look at the functions. Okay, apa yang boleh sekarang ni? Linear regression. Can you do linear regression?
Not anymore.
Not anymore. Okay, and then you can use multi-layer perceptron. You cannot use simple linear regression, but you can use simple logistic. Okay, let's have a look. 3 pula. 3 now. Okay, tadi you cannot use J48. Now you can use J48. So to answer your questions, not necessarily we have to delete the continuous attributes, but it's actually depending on the algorithms, the capability of the algorithms to deal with the attributes. There are certain algorithm has the limitation. Okay, the limitation we need to understand if we have continuous data, okay, and we want to implement the algorithms. Okay, I really like J48 katakan. Okay, I really like J48 ataupun I really like just now linear regression. Kamaru kata nak guna juga linear regression walaupun data saya nominal. Okay, how to do that? How are you going to deal with this? What do you think?
Change the nominal into numerical values.
So yes, that's right. Means that we have to represent the value of outlook into numeric. Means that probably we can use sunny represent by 1, overcast is represented by 2, and rainy represented by 3. Okay, and then you probably will, when you change the representation, you probably will get the linear regression allowed. Yeah, is allowed for your data set. Tapi again, remember, when you want to change, again, you have to understand whether it's suitable or not. Yeah. There are certain cases you have to be very sensitive and very precise representation. Means that it can simply change into different representation from nominal to numeric. But certain time, you cannot simply change it into another way of presentation. Okay. So it depends on the situation, yeah. Whether you need to be sensitive on the representation or you need to be sensitive to the model, yeah, the modeling itself. Okay. Okay, Kamarul? Boleh?
Thank you.
Alright. Okay. So hari ni saya tak buka video, tapi tak apalah. It's okay kan? You can follow. Anything else? How about kawan-kawan perempuan semua? Senyap je.
Alright.
Okay je.
Okay. Ya. Kita dah start tengok menu untuk apa? Planning untuk bersahur. Kena masak lah malam ni.
Bagus Amirul. Madam sahur apa pagi esok?
Apa dia? Ha?
Sahur apa pagi esok?
Masya Allah, saya pun tak terfikir. Saya silap telur goreng je besok pagi ni. Ha?
Alhamdulillah. Menu favourite lah.
Oh ya, kan? Semua orang bangun terbau. telur goreng dengan ikan kering, mesti semua terbangun.